All right, we're rolling. Good. R2, exponents. Let's put that up, please. All right. So there are 10 laws of exponents, okay? So what you're going to see for exponents, there's 10 laws. And I want to say, like a mathematician is like a mechanic, where a mechanic has to have what in their toolbox? What do they have to have? Tools, right? Okay. And they have to know what about the tools? How to use them, where to use them, when to use them. If a mechanic has no tools in their toolbox and then they want to fix a car, are they going to have some problems? Yeah. So same for you guys. The math becomes easier the more laws and the more rules you know. And then you be able to know shortcuts and make your life easier for it. So that's what we're trying to do, is fill this up with our exponent rules today. And then we'll see how that is used in the homework. Okay, so let's get started. What is the first, most basic rule of exponents? When we talk about an exponent, who thinks that they can tell us the first or the most basic rule? Like, what does an exponent mean? Yep. That's exactly right. The amount of times that a number is multiplied to itself. So the first rule, if we said, so what does an exponent represent? Then that is, if you have like 2 cubed, the 2 for, this is what you were talking about, like maybe some terminology. The number here is the base. The number up in the top right, that is the exponent, okay? So if we have 2 cubed, that means to do 2 times 2 times 2. Okay? How many times did you multiply by itself? So the way, every time I do a rule though, I don't want to use a number, I'm going to use letters so that it stays general. So like if we have a to the m, that means to do a times a times a, dot, 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 times a. How many times? M times. There you go. There's your first rule of exponents. And then as we go and develop other rules, we always want to come back to this one. So this rule kind of sets us up for the other rules. Okay? All right, very easy. Everybody good with that? Okay. Second rule. What do you do? So what if we had 2 cubed times 2 to the 4th? Does anybody know what's the shortcut you can do with those exponents? Yes, Hank?
Add the exponent.
You can add the exponents. So you would write this, the base stays the same, you would add the exponents, and that becomes 2 to the 7. That's exactly right. So the question is, that is the rule, but what I also want to do is look and see why that is a rule. So the way we write this out, so he's right, when you multiply and the base is the same, you can add your exponents. So if we have a to the m times a to the n, it's a to the m plus n. So when you multiply, you can add your exponents, but my question is, why is that a rule other than you told me, right? And that's how we were taught. Why does this make sense that you add them? Yes, but still, I don't understand. But okay, the bases are the same, but why don't I multiply? Why don't I say 3 times 4 is 12 and do 2 to the 12th? Why is it that I have to add? Yeah?
Since the base don't have terms, then they can just be combined together.
Okay, all right. So let me ask you this, what does 2 cubed mean? All right, so we always go back to rule 1, right? From what Maria, right? Rule 1, 2 cubed means 2 times 2 times 2. And this is a multiplication. So there's another times. What's 2 to the 4th? So you're right, you have the right idea. You say, well, since they're all 2s, if you write it all out, you're going to write out 3 2s and you're going to write out 4 2s. Well, if you write them all out, you have how many 2s? 7. And that's why it's 2 to the 7. Okay, that's why you add, because we're back to rule 1. How many 2s are being multiplied? The reason you want a shortcut is this, is because if I have 2 to the 9th times 2 to the 15th, I don't want to write them all out. That's why I want to know the rule. I want to know that the rule is 2 to the 24. It's okay, we're rusty. Well, I've been in quarantine. Nobody's done math. Y'all been watching the YouTube and all that. Okay? Then you got variables. Maybe you have x cubed times x to the 7th, then that would be x to the 10th. Okay? Everybody good with rule 3? So far, so good? I mean, rule 2. All I've done is this math all day. You go crazy after a little bit. All right, the next one deals with division. So what do you think is the rule when you divide and the base is the same? If you multiply and the base is the same, you add exponents. What do you think the rule is when you're multiplying and the base is the same? Subtract. So let's look at why it is subtraction, okay? So let's say we have 3 to the 5th over 3 squared, okay? Let's look at, see. So you're saying that the answer should be 3 to what? To the 3rd. 5 minus 2, which is 3 cubed. That should be the answer, okay? Which we could then do 3, I think we could do 3 cubed in our head. 3 times 3 times 3 is what? 27, very good. But let's look at why it's takeaway. So always go back to the first rule. Maria, 3 to the 5th means do what? I guess, yeah, 5 threes, right? And 3 squared means 3 times 3. But when you put them in a fraction and now you put the same number underneath, what can you do with these 3's here? These 2 3's can do what?
Cancel.
They cancel. What do these 3? What happens to these 2 3's?
Cancel.
They cancel. And what have you done from the top? You have taken away. You have taken the 2 from the bottom, you took it away from the top, and that's what you have left. You're left with 3, those 3 3's, which is 3 cubed. So that's why it's subtraction. Yes?
What happens if there was like 3, 6, and then under would be like 4, 2?
Well, if it's not the same base, we can't do anything. We can just get the numbers and then go from there. We're just looking for shortcuts. So if the base is not the same, like if it's 3 squared over 4 cubed, I gotta just work it out. Right? 3 squared is 9, 4 cubed is 64, and that's it. I can't do it. I can't reduce it. So it's a good question. Okay? So we subtract. Real quick, what is anything to the 0 power? 1. 1. I thought you were going to ask this question. Okay? So the question I thought she was going to ask is, what if the bottom was bigger than the top? Like, what if we had 2 cubed over 2 to the 8th? Right? Well, what? Because you can't take away, if you take away 8 from 3, which we can do. So if we just use the rule, what should the answer be to this one if we use rule 3? The answer should be what? 2 to the negative 5. That's exactly right. But in math, a negative exponent is kind of taboo. It's like something like we don't want to write the answer with negative exponents. Why it's a bit, I could go into like in calculus where it makes things more difficult, but you don't really want to go to sleep right now, okay? I could tell that story later. We film it. You can't fall asleep at night. You watch it, then you would fall asleep, okay? But let's just say it's taboo to have a negative exponent. How do we change it to positive? So let's do the rule, and I'm going to show you that this is equal to something else with a positive 5. So if we write it out, 2 times 2 times 2, 2 cubed, right? 2 to the 8th. 2 times 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 2. This is why I drink a lot of coffee. You got to write these numbers on there. Now, if we do the math on this, and I start taking away, these 3 2s will cancel, right? What does it leave me with on top if I cancel all the 2s? 1. Leaves a 1, because when you're canceling it, you at least have a 1, okay? Because 2 over 2 is 1. See? What am I left with on the bottom? So what's 5 2s multiplied? 2 to the 5th, very good. These are equivalent. It's the same answer. So 2 to the negative 5 means 1 over 2 to the 5th. And now we've just derived rule 5. If you have a negative exponent, you can change its location in the fraction and make it a positive exponent. I'm sure you've seen this rule before. Maybe I'm hoping it rings a bell, but that's it. And it works the other way. You can move it up. So if you have a negative exponent in the bottom, you can move it up. So rule 5 is, if you have a to the negative m, it's 1 over a to the m. Or if you had 1 over a to the negative m, it's a to the m. So this changes its location in the fraction and becomes positive. So let me just show you this one. Let's just say you had 1 over 3 to the negative 4. Leah, according to the rule I just wrote, what does this equal? Yeah, 3 to the 4th over 1, you just call it 3 to the 4th. So you know the rule. I like to show you why, though. Like show you, how can I show that this is true, right? Because you can't really write out, how do you write out 3 multiplied by itself negative 4 times? You can't. So let me show you why this is true. So first of all, if I want a 4, I'm gonna put a 4 up here, but I'm also gonna multiply the bottom by 3 to the 4th. Because in math, as long as I multiply by 1, I'm not changing the value. Does everybody agree that this 3 to the 4th is 1? 3 to the 4th over 3 to the 4th is 1, because it's the same number. So I'm not changing the value. And then the rule in fractions is this: when you multiply across the fraction. So 1 times 3 to the 4th is what? So there's your 3 to the 4th in the top. Now look at the bottom. 3 to the negative 4 times 3 to the 4. What's the rule when you multiply and your base is the same? You add. What's negative 4 plus 4? What's anything to the 0? Bam. There you go. So you don't have to do that every time. You just know it changes its place in the fraction and becomes positive. Okay? But that's the math behind it. Okay? How many rules is that? 5. I hope so. Yeah, we got 5 rules. So that goes with it. Okay? All right, rule 6. All right, I got to erase. We're okay. I'm going to try to fit. I'd like to leave all 10 rules up. I may have to put like 8 and 9 up there or something. All right, rule 6. All right, let's see. What is the rule? You have a power raised to a power. What do you do? Multiply your exponents. So the answer should be 3 to the 2 times 4, which is 3 to the 8. All right. That's exactly right. That's the rule. So let's talk about why that's the rule. So a power raised to a power, you multiply. So let's talk about why. If I cover this up and I just say something to the 4th, what does raising to the 4th power mean? That's exactly right. And that's what's going to be multiplied. So this, if I drop down, I'm just showing you the work. You don't have to do this as long as you know the trick, but I'm just showing you the why behind it. This means 3 squared times, and then I stop. So that's what this means. And then when I multiply and what I do with all the exponents? I add them. So this means 3 to the 2 plus 2 plus 2 plus 2. Well, adding 2 up 4 times is the definition of what? 2 times 4 is multiplication. Here's your 4 2's. So nobody wants to go this way, you just want to remember the shortcut, okay? And so the rule is a to the m raised to the n, okay? Is a to the m times n. Okay? That's the rule. So far, so good? Rings a bell? Okay? Rule 7. I get it. Am I okay to erase my work there? Okay, sorry. I'm running out of room. I think I can put rule 7 here. Rule 7. All right. If I have 5x cubed. So now I have two things multiplied, but they're raised to the same power. So I have 5x cubed. We know what it means, but like what does 5x cubed mean? It means to do what? 5x multiplied by itself 3 times, but there's a rule. I can do something with this power. Where can this power go? So I want to see if you know the rule. It goes to the 5 and to the, very good, it's kind of like distributing. So you get 5 cubed times x cubed, and that's exactly right, that's the rule. So I want to show you again, how can you do that? How is that legal, right? So this is the rule, the 3, it raises to each one. And the reason is this, like what you said, Sonar, you said it means 5x times 5x times 5x. And then multiplication, you can rearrange the order, it all multiplies. 5 times 5 times 5 times x times x times x. 5 cubed x, nobody wants to do this. You with me?
Yeah.
Yeah, see, I can change the order when it's multiplication. Everything's multiplied. You agree with this, 5x cubed is 5x times 5x times 5x, right? Okay. So why do I want the shortcut? Well, what if I had x times y to the 10th? Nobody wants to do x, y, x, y, x, y, x, y, x, y, x, y. Just know that you raise each one to the 10th. X to the 10th, y to the 10th. Okay? All right. So the rule is going to be, if I have a times b to the m, it's a to the m times b to the m. Now let me give you an example of what you're going to see in the homework. So we'll call this, it still is rule number 7, but let's just do an example. All right, let's say we have 2x cubed y to the 5th, y to the 5th raised to the 4th. Okay, so first of all, everything inside the parentheses, what operation, what are these 3 things being multiplied? So the rule is, if you have multiplication, you can raise each part to the m. So you can do each of these to the 4th. But notice these already have exponents on it. So you're going to have to do 2 rules in 1. So take a second, see if you can raise each part to the 4th and see what you get, and write your answer in the most simplified form possible. Okay? So I'm just going to say simplify. Okay, ready? All right. Is it Ashton? All right, so the first thing we need to do is what, Ashton? Well, before that, I'm just gonna go really basic. I'm gonna take each one and raise each piece to the what power? To the fourth. So we're gonna say 2 to the fourth times x cubed to the fourth. So say I'm putting parentheses just to show, and then I'm doing y fifth to the fourth. So right now, I'm doing rule 7. Okay? Now, 2 to the fourth, I'm hoping you could actually work that out. Do you know what 2 to the fourth is? You got it? I thought you had it. 16. Sound like you were gonna say it, yeah. And then now, notice how you have 2 rules in one. So now you have x cubed to the fourth, power to a power, we do what? Multiply, so you get x to the 12th and y to the 20th. There you go. Okay. Everybody good with that? Question? No question? Anybody has a question? So what was the first thing I did? What rule is this? Rule 7. Then, yeah, it's basically distribution, right? And then I have a power to a power, I'll multiply. So I do rule 7 and rule 6 together. All right, now let's look at rule 8. We're in our room. Rule 8 says if you have division to a power, you can raise each of those to that power, a to the m over b to the m. So I'll show you what I'm talking about. Am I okay to erase my work? Paige, are you good?
Yeah.
Okay, I don't want to erase something. The good thing is it's on video. You can always go back and watch it. Okay, rule 8, x over 2 cubed. I'm just doing something basic, right? What does it say? What does rule 8 say we can do? What do I do with the cube? Put it to the x and to the 2. So you should get x cubed over 2 cubed. What's the D word you want to use there? We're basically distribute, yeah. Okay. And then hopefully you can figure out 2 cubed, right? You would write it. So the question is, why is that? Why are we allowed to do that? Why is that a rule? Why can we distribute the 3? So I'm going to go back to asking you this question. Allison, what does cube mean? So what do I got to multiply by itself 3 times? Yeah, so I've got to do x over 2 times x over 2 times x over 2. You don't have to do this. I'm just showing you the why. Why is this a rule? So if I multiply a fraction, what's the rule when you multiply fractions? You multiply across. You multiply fractions, you multiply all the top and you multiply all the bottom. So x times x times x multiplies to give me x cubed, right? 2 times 2 times 2 multiplies to give me 2 cubed, or what's the answer? 8. That's it. All right? Yeah, I know. So now you could have 2 problems in one. You could have rules 6, 7, and 8 all together. So you see how it kind of can snowball. So if we did an example of this, let's say we had 2x cubed y to the 9th over z to the 8th raised to the 4th. So notice, I've got multiplication and I have division. So where's the 4 going to go? Guess the one that students forget has to have the 4, the 2. They'll put their answer 2 times, and it's got to be 2 to the 4th. Oh, we already did 2 to the 4th. That's all right. So see if you can do this one. Okay? So you're right. The 4 has to go to every piece. Each piece is raised to the 4th. Christina, would you like to give us your answer?
I just used the full math and I got 2 to the 4th. It might not be like simplified all the way. So.
All right, well, tell us what you got.
2 to the 4th times x to the 12.
That's right.
And then y to 36. And then that's over 2 over 3.
Well, that's a z.
Oh.
That's a z, sorry. See, I put a line in the middle so you know it's a z. So it's z to the what, though? 32. And 2 to the 4th is 16. So you go ahead and do that. There you go. Yeah. All right. I see a question. You have a question? I see Hank has his calculator. So you're going to help us out, Hank, on rule 9. Really, we only have one rule. Rule 10 is kind of trivial. So we won't worry too much about rule 10. So rule 9, here's what I want you to do. You're going to type this in on your calculator, but don't tell us the answer. So he's going to do 1/2 to the -2. So you get a negative exponent. And it's hard to work it out with a negative exponent because you're like, well, how do I raise something to a negative power? So he's typed this into his calculator. He has an answer. So I'm going to show you the rule 9, what rule 9 says. So let me erase. Can I erase this scratch work from the previous? Okay. So there's, let me erase that. We're going to put rule 9 down here. So rule 9 says if you have a fraction to a negative exponent, you can flip the fraction and make it positive. So, yeah. So if you go up here to this, Hank, you type this in on the calculator. Yes, so you know the answer, right? So let's do what the rule says. It says if you have a fraction to a negative, you can do what? Flip your fraction and make the exponent what? Positive. Which problem looks better? The one on the left or the one on the right? The right, yeah. And now you're just left with 2 squared. Well, what's 2 over 1 squared is what? 4. What did you get?
I got 4.
You got 4. That's it. Okay, does everybody see the rule there? So he typed it in on his calculator just to show that we got it. So, like for instance, here's how you might see it with variables. You might have x squared over z cubed raised to the -5. Well, you could distribute the -5, but now you're going to have all negative exponents. So I like to get rid of my negative exponent. It'll even tell you when you go to my math lab and type it in, it'll say no negative exponents. So might as well get rid of it right from the start. So if I use this rule, I can go ahead and do what? Go ahead, Paige. Yes, flip it and change the exponent to a positive. And then you work the problem. Okay? So whatever's down goes up, whatever's up goes down, and make it positive. And it's basically from rule 5. See how you change the location? It's basically putting rule 5 there. Okay? But then you got to finish the problem. I think we can all do this one in our head, right? So what would you get? Z to the 15 and x to the 10. There you go. Easy peasy? All right, good. Lemon squeezy, that's right. Okay. And then the last rule is kind of trivial. I'm just putting it. I don't think we'll do much with it. It says that a to the x equals a to the y. So basically, if you ever have an exponential equation and the bases are the same, let's say you have 2 to a power equals 2 to a power. The only way that these can be equal, what do you think the exponents have to be? The same. So it's just basically saying then x is y. So like if I had 2 to the x equals 2 cubed, you know x has to equal 3. That's all it's saying. We won't use it, but it's the 10th property of exponents, so I wanted to give it. But you won't need rule 10 for your homework. Okay? So now what I want to do is, do you have these rules? They should all be in your notes. I'm going to erase the board. I'm going to put a couple of more difficult problems that relate to this from the homework. We'll try a couple, and then I'm going to turn you loose on my math lab, okay? Sounds good? Okay. So I'm going to erase the rules, but we should all have them in our book. one problem. I think if we can get this, we'll be good. This is an S on this one, not a 5. It's an S. So here's the thing, you're gonna simplify and you're gonna only have positive exponents in the answer. Simplify, you can only have positive exponents in the answer. Now, what I'd like you to do is work on it. Don't break your social distancing, but talk to each other, kind of compare your results on your answer. And we'll spend a couple of minutes on this, and then we'll get you working on the work, the homework. Yes, ma'am.
So if I flip the fraction, does that also count for the base number? Like the 24 would be from a negative?
No, because that's not an exponent.
Yeah, it's just direct on it?
Yeah, it only works on exponents. So that can go up. This negative 24 doesn't go anywhere, it's just a negative. Just a negative number. It's not an exponent, it's a 24.
Yeah.
Okay, follow me? Yep. Only what has the negative exponent can be moved. All right, you can't move everything. The rule for moving is only for negative exponents, not negative numbers. Okay. So on this first problem, only one little. If you want to move anything, that's the only thing that can go up. Time out, look up here. Think about this. If I gave you this question, 10 over negative 2, what's the answer? What's the answer? 10 divided by negative 2, what's the answer? Negative 5. You don't move this up and multiply. It's a number. Numbers have different rules than exponents. So 32 over negative 24 you handle one way, the exponents you handle another way.
Can we switch? So we're bringing the y to negative 3.
You can, I wouldn't. It depends on how, I mean, there's different ways to work the problem.
Okay.
At the end of the day, though, you should have a y to a positive exponent somewhere. Yep.
I think the third rule, does that also apply to numbers?
That's only for exponents.
So what do you do with the numbers?
Pretty good stuff. What would you do with this? 12 over 8.
To 6 over 2? Or, 6 over 2.
You got the idea.
Yeah.
But there's a 4 that can come out of those, right? So this is 4 times 3 and 4 times 2, 3 halves. And it's same idea. So 32 over negative 24 will reduce. It just won't be pretty. It's good questions. You basically, on the first problem, have three separate problems to work. Simplify the numbers, deal with the x's, then deal with the y's. Those are the three problems that you have to do. It should reduce. It's a fraction. It should reduce. I would ask myself, what's the biggest number that will go into both, and then that way I can cancel that out. Okay. Well, is 32 divided by 24 going to give you a whole number? No. Okay, so let's look at the first problem. All right, so here's where my eyes go. This is what my eyes do. That is one simplification. 32 over negative 24 has nothing to do with exponents. X cubed over x to the fifth, y over y to the negative 3. So these two here are going to deal with rule 3. I'm going to use rule 3. That I'm just going to reduce 32 over 24 with a negative. I can put the negative wherever I want because it's with the numbers. Doesn't matter. So I ask myself, what's the largest number that goes into 32 and 24? The same number, because then that's what I'm going to cancel out. 8. Very good. So I'm going to make this, the top is 8 times 4, the bottom is negative 8 times 3. You still got your x cubed over x to the fifth, and you got your y over y to the negative 3. So now those 8's cancel, and you're left with what? What fraction? It's kind of, you can leave the negative in the bottom, but most of us put the negative on the top. It doesn't matter, because it's still a negative 4/3, whether you 4 over negative 3. So that's negative. All right, there's that. Okay. Then now I've got to use my division rule. What does it say I do if the base is the same? So that would be x to the what? Negative 2. Y to the what? How do you do, because if there's not an exponent, what's the exponent on y? What's understood? 1. So what would the exponent for y be? 1 minus negative 3, which is what? No, positive 4. 1 minus, you subtract, positive 4. Or you could have moved this up, y to the first times y cubed, y to the fourth. Yeah, it's going to be y to the fourth. Yeah, so what do you get? You got negative 4/3. Where's this x going to go? X to the negative 2. You're going to leave it there, or you're going to move it? Move it where? To the bottom, and the top should be y to the fourth. That should be your answer. Okay. So I'm using the rule where it says you subtract 3 minus 5, and this was 1 minus negative 3. Okay. All right. Did that help a little bit there to see that one? Now let me give you a hint on this. The 36 over 9, should that be easy? Yeah. Get that out of the way. Then I see there's a RST, so I'm going to get R to a power, S to a power, T to a power. Over R to a power, S to a power, T. I'm putting question marks because I'm pretending I don't. And then I would deal with each one separately, just like I did here. So I would probably distribute these exponents, and then we look at each column of ones and simplify each one. Okay? I know those are sweetly crazy looking question marks, but I didn't want to write the numbers. You already get rid of that. That's going to leave a number on top. Okay. What happened to the 36 over 9? That becomes what? 4. So we're going to go ahead and do that. Now, the top is just an r to the negative 1. I'm going to leave that alone. And then what do I have? I have st quantity squared. So where can the 2 go? Yeah, s squared and t squared. So you got that. See what I'm saying? I would just go ahead and put each part so that I can then go and use my rules. Okay, everybody see how we did that? So all I did was square both of those. Then the 9's gone on the bottom because this went into 36 4 times. Now the square goes to both the what? R squared, s squared. So notice now, you see what's going to happen to your s squares. They're going to cancel, and then you got times t to the negative 1. So those cancel because they're the same. Okay? Then I'm going to use my rule. My rule says what? When I divide, I do what with my exponents? So it's the top one minus the bottom one. So I'm going to get 4r to the what? Negative 3. We'll fix that in a second. T to the what? So think. You can either leave this. 2 minus negative 1 is going to end up doing what with the 1? Plus 1. So to the 2 minus negative 1 makes that a t cubed. Okay? So then your last step, so you have 4r to the negative 3 t cubed, which I think looks good, but what's taboo? And so where do you put your r to the negative 3? In the bottom. 4t cubed over r cubed. And that's it.
You do it that way.
Why did we get 2 again?
2 minus negative 1 changes that to a plus 1. Right, you with me on why it's a why I do a minus? See, the rule of the, oh crap. I ran, see, I went past my border. Whoops. 4t cubed over r cubed. I'm using, see this rule right here is the a to the m over a to the n. And you do m minus n. So I'm going to do minus a negative 1, 2 minus a negative 1. Or look at it like this. You can move this up and say times t to the first and then add. Either way. Either way, you're going to get a t cubed. Okay. All right. So, you're going to get plenty of practice in the homework. The homework right now is due Friday, but since I'm not going to see you Friday, and we'll see you Monday, I'm going to push it to Sunday night. I would not wait till Sunday night to do this. Okay? All right, I have to stop this because it's 44 minutes. It's going to take it 20 minutes.